Welcome to my lecture. Today we are going to solve the third question, solving the linear system of equations by three known methods, namely inverse method, Cramer's rule, and the Gauss elimination method. So our first method is the inverse method. We will check it that it is possible to solve it by inverse method. For that we write the system as Ax is equal B, where A is the coefficient matrix, X is the variables, and B is the constant 2, 3, 6. So first we check the determinant, and determinant is coming as 10. So it's not equal 0. So therefore the system can be solved all of the three methods, and the system will have the unique solution. So let's start with the inverse method. For that we calculate the adjoint as usual process, and we got the adjoint of A is equal this matrix, and then we will take the inverse. So we know that inverse is equal adjoint of A divided by the determinant of A. So determinant is 10, so it will be 1 over 10, and then we will write the matrix as above. Then the vector x can be written as A inverse B from the relation Ax is equal B. Then we will take that inverse and multiply it, so you will get 1 over 10, 10, 10, 10, and then finally the answer is 1, 1, 1. So that is the solution. X is equal 1, y equal 1, and g equal 1. Now next we will use the Cramer's rule, and for that we will follow the same as previous, and then we calculate the determinant, which is 10, and as mentioned before, that system will have unique solution. So now we will take D1. D1 is from the matrix A, replacing the first column by the vector B, and then calculate the determinant D1, which is equal 10. Same way we calculate D2 by replacing the column 2, and then it is also coming 10. Third, we do D3 by replacing the column 3, and it is also coming 10. So therefore the solution will be determinant D1 over A, determinant A, which is equal 1, y equal determinant of D2 divided by A, which is equal 1, and g is equal determinant D3 over determinant of A, which is equal 1. So the solution is 1, 1, 1 as previous method. Now we will solve it by the Gauss elimination method, and the system can be written as usual before. And now we just write the coefficient matrix and the constant, and we make the augmented matrix like this. Then we do the operation here, R2 as R2 plus 3R1 and R2 minus R1. So to make this column 0, so which is coming now in this form. Then for the next target we will make it R3 minus R2. Then the new matrix, equivalent matrix, will be like this. So last one is minus 5, 5. So we'll divide it R3 by R3 minus 5. So to make the last row entry is 1. So now after reduction, this matrix is look like this form. So from this, if we consider the last row, we will see that this is equal, g is equal 1. Then from the second row we have 2y plus 7g equal 9. From the first one we will have minus x plus y plus 2z is equal 2. So from now we will do the back substitution method to solve the equation. So we know g is equal 1. Then from the second equation we have 2y equal 9 minus 7g, so which is equal 2, and then it gives y equal 1. Now from the third equation we will have x is equal minus plus y plus 2z. So this will gives us equal x is equal 1. After substituting the values g equal 1, y equal 1, we will get x is equal 1. So this complete the solution.